Okay, so, yeah, when we're completing the square, if we're gonna solve it by completing the square, what's the first thing we gotta do? We gotta put it in what form? And we gotta, remember, we gotta set it up to complete the square. How do we do that? What would we do here? What would the specific thing we do here be? Subtract 11, good. And the reason being that we want to get it into the form x squared plus bx equals some number, right? So that we can complete the square. Then, next step is complete the square so that we can have a single x. We can write our quadratic equation with a single x after we complete the square. And then once we have a single x, what's the last thing we do? We can write an equation with a single x that we can point to. What can we always do? Isolate. Yeah. Then we isolate x. Okay, so you already told me, for step one, all we have to do here is subtract 11, right? Okay, good. So we're there. Right now, this is set up to complete the square. All right, so if we're going to complete the square, we know that on the left side, once we write it like this, we can always get the left side to look like a perfect square with a single x. Okay, so what's the number that's going to go with x? 3. Good. It's going to be half of 6, isn't it? So then what does that mean we have to add to both sides? Up above. 9. Good. Right? Make sense? Okay? Because we needed, that 9 has to be there in order for this trinomial to factor into x plus 3 times x plus 3, or x plus 3 squared. So then on the other side, what are we left with? What's negative 11 plus 9? Negative 2. Okay, so we got it. We completed the square. We wrote our quadratic equation in terms of a perfect square with an x in it, right? And so now all we have to do is isolate x, right? So to isolate x, that's no big deal. To isolate x, what's the first thing we're going to do?
Radical 2.
I'm going to square root both sides. Very good. So if we square root both sides, it cancels the squared. Right away, I'm going to go ahead and add my plus or minus. As we always know, if we square root both sides, we need a plus or a minus. And then what's going to happen here, though? I've got the square root of a negative number, so what's that always going to give us?
Something I.
Good. It's going to give us an I. And then what are we left with times I?
2.
The square root of 2, right? We can't simplify that radical, can we? But at least we took the negative outside and made it an I, right? So then on the other side, we're just left with, we got rid of the square root, so we have x plus 3, and so what's our last step going to be? Subtract 3, good. Where's it go? In front of the plus or minus, good. So we get negative 3 plus or minus the square root of 2 times I. And the I is outside of the radical, right? And I got to, of course, put in both answers separated by a comma. The plus, comma, then the minus, right? Okay, questions on that? Good, good. Okay, here's the next most commonly missed one. How about this guy?
That's 2 x's, so then you can't isolate x.
Right, so what do I have to do then?
X plus bx equals b.
Okay, good. So that means I got to get rid of the 21, right? So I'm going to subtract 21 from both sides. Okay, good. So now we're set up, good, we're set up to complete the square. So Trent, finish your thought there. What's going to go with the x?
It would be negative 4?
Negative 4, right? Because it's got to be half of b, right? B is the coefficient of x.
So then it would be negative 12 to both sides?
No. What's going to go, so what's that going to be? 16, good, because negative 4
Oh,
squared
Squared. I thought you just
is
took
gonna
the
be
other one,
16.
and then you just added like 8 plus 4.
Oh, no, whatever goes here has to be squared there, okay? So then what do we end up with on the other side over here?
-5.
Good, and this is just like the other one, isn't it? Then we'll square root both sides, and so if we square root both sides, to get rid of the squared, I'm gonna get a plus or minus, right?
Radical 5. Radical -5i.
Good, and we've got our negative inside, so that's gonna become an I outside. And then the square root of 5 I'm stuck with, that doesn't simplify, right? And so what's my final answer gonna be? Square root of 5i, that's it, good. Okay, how about this?
There's only one x, so therefore you can complete this.
Yeah, we can solve this one by isolating, we don't have to square this time, do we? So what do?
Subtract 2,
Subtract 2,
392. Then you have to deal with the exponents, right?
oops,
Oh, 4 first. Divide by 4.
good, we're gonna divide by -4, everybody agree?
And
So
then
we're gonna get, if I divide both sides by -4, I get x squared equals
96. 92. 86.
98.
Oh, that's not too bad.
Negative 98, right? Okay, everybody agrees it's negative though?
Yep.
So now when I square root both sides, what's that gonna give me?
Something I.
So x is gonna be plus or minus the square root of -98, which is gonna give us plus or minus the square root of 98i. And if we make a factor tree out of 98, what can you tell me? Well, it's even, so 2 times what?
7.
Well, okay, I mean, I know what you're saying.
49. And then 7.
49, which is 7
I'm not
squared,
too
yeah,
far off.
that's good. So we end up then with, we got a couple of 7s, right? And a single 2, and so we're able to say x equals plus or minus 7 radical 2 I. Okay, good? All right, I think you guys are in pretty good shape on this.
Thanks.
How about this one?
It's because I tuned up last night.
Nice, nice.
What are you laughing at?
That's just good. I'm just glad you tuned up last night. That's good. A little math tune-up never hurts, does it? All right, so what are we gonna do here? Now, this is one. There's a couple ways. I'm okay doing this different ways. What's one thing we could do? Okay, we could add 18x to both sides. Good, and then we get 3x squared.
Zero.
Whoops, minus 18x, right? Everybody agree?
Yep.
If I add 18x to negative 36x, I'm left with negative 18x plus 36 equals 0, okay? Now what?
Plus or minus 36.
Okay, one thing we could do, and that's fine, and I'm gonna go ahead and, let's just split the board here, because I want you to see that this is all gonna work out. One thing we could do here is we could say, okay, then let's go 3x squared minus 18x equals negative 36. Okay, now what?
Something with the 3.
So you probably should do this, huh?
Well, you've got 2 x's, so therefore you cannot complete the square.
I mean, you can't isolate x.
Oh, that's right.
We're gonna have to complete the square. What are the 2 things that I've gotta do on the left, though? Or one thing, we already got rid of the number, now what?
Times 3.
Gotta divide by 3, don't I, right? Gotta divide both sides by 3, but if I divide the left side by 3, I can divide the whole thing by 3, but really I'm gonna end up just splitting it anyway, right? I'm really just dividing each term by 3. Give me a thumbs up, sideways, or down on that. Does that make sense? If I'm gonna divide the left side by 3, I can just do that instead. Thumbs up, thumbs sideways, thumbs down. Let me
Well,
see how we're
aren't you doing
feeling
that
on that.
already?
Okay, we're good with that?
What about 36?
We gotta do that side too, you're right, we gotta divide both sides, but I'm just talking about the left side, does that make sense? Okay, okay, so then what's that do for us? That's helpful. Then we end up with the 3's canceling, and I get x squared minus 6x equals negative 12, right? Okay, that's good. And so, now all we have to do is complete the square like we've always done, right? So, what's gonna be the number that goes with x? That goes with x? Negative 3, good, good. So here we've got negative 3, but to get that, what number do I have to add to both sides? Good.
3 squared.
Negative 3 squared is positive 9, which is going to give us negative 12 plus 9 is what, negative 3? Okay,
And that's gonna give us an I.
that's going to give us an I, good. So now we'll just square root both sides.
Plus or minus.
Got a negative there, so we know we're going to get an I. Right, and we know we're going to get a plus or minus, good, that's probably the first thing we should always do. And then what am I going to get on this side? So I'm going to get square root of positive 3 times I, good. And then over here, I'm just going to get x minus 3, so my final answer is
3 plus minus 3x.
there we go. Okay. The only other thing that I could see that somebody might do differently would be to, when we've got this thing in standard form, the way we talked about it before, but I don't care. I mean, it works, that's fine. The way you did it there is just fine. You could also say, okay, well, all these are divisible by 3, right? And so we could divide everything through by 3, both sides, but 0 divided by 3 is 0. Anything divided by 3 is 0. Or 0. Anything divided by 3 is not 0. 0 divided by anything is 0, right?
Are you sure it's not 3?
There we go. So now that would just give us our x squared minus 6x plus 12 equals 0. But we're ultimately going to get to the same spot anyway, aren't we? We're just going to subtract 12 from both sides. So take your pick. I don't care. Take your pick. Okay? Questions on that? Okay. This group seems to be in pretty good shape on this stuff. How about this one? What's different here? Well, not really much, but what do we have to do? Okay, you gotta move the stuff on the right to the left. So I'll add 6x. So what's that gonna give us?
11x.
Good. We're gonna subtract 4. Right? And you might be saying, well, why don't we just leave the 5 over there? You could, but we want to get in the habit of doing this for 2 reasons. Because first of all, we want to be able to, in the future, we want to be able to say, okay, is there an easier way? Could I find a magic number? Multiplies to 5 and add, no, we can't, but at least we tried, right? Then the other thing is, remember, we actually I showed you guys the quadratic formula. That's what we're kind of going to work on next, practice that. So we've got this thing in standard form. And so now we could just use the quadratic formula also, right? Make sense? Okay. So we're going to complete the square this time. So we know that we got to move that 5 over. Okay, so now we can complete the square, but this time it wasn't quite as convenient. What number goes with x? 11 over 2, right? Whatever's in front of the x, we're going to divide that by 2. So that time we have a fraction. It's all right. You know, I know fractions are a little bit scary. They raise your blood pressure a little bit because they make math a little harder, but they're just numbers. So what's going to go up here on it? If that's an 11 halves, what are we going to add to both sides? Well, but what do you have to give me the exact answer. What are you going to do with this, though? We're going to square it, aren't we? If we square a fraction, we just square the top and square the bottom. What's 11 squared? 121. There you go. And then 2 squared is 4, right? Okay, so on this side, we'll add our plus 121 over 4. And then all we gotta do is figure out what these numbers add up to. But how do we add -5 to 121/4? Ah, good. Okay, so we'll write it as a fraction, and then we'll multiply the top and bottom by 4, right? And then that's gonna give us what? We're gonna get -20/4 plus +121/4 is what? What's on the top? 101, good. On the bottom, we just got a common denominator of 4, right? Okay, so. And then now we completed the square, right? We've got this quadratic equation written with a single x, right, inside a perfect square. And so what are the steps always going to be? Square root, and then either add or subtract, right? Okay. So if we square root both sides, get rid of that squared. What am I going to write before I do anything, probably? Plus or minus, good. And then on the right side, what are we going to get here? So square root of 1, when I have the square root of a fraction, well, first of all, I'll try to reduce that fraction, but it's not going to reduce, right? So then I'll just split it into the square root of the top over the square root of the bottom, right? Well, the bottom is good. Square root of 4 is what? 2. 2. Okay, that's good. But the top, I think we're stuck with 101, aren't we? There's not going to be any perfect square factor of 101. That's going to end up, there won't be any couples when we do our factor tree. In fact, I think 101 is probably prime. Okay? But either way, we're stuck with square root of 101. What then? So now on the other side, we've just got x plus 11/2. So what's our last step?
Subtract 11/2.
Good. So remember, we're going to put the negative number there. No Y's this time, are there? There we go. Okay. All right, how about this guy? What are we gonna do?
Add x squared and 9x.
Okay, but we're gonna not add x squared, what are we gonna do? Subtract x squared, good. So that's going to give us, everybody agrees, 3x squared on the left then. If I add 9x to -24x, what's that? -13x, good. Okay, and so now, I mean, maybe we could find magic numbers there, but honestly, are you probably going to want to use bottoms up ever again? And you can, if it works, but probably, just thinking into the future, what are you probably going to do if you end up with an a that's not equal to 1? I know what I would probably do. What would you do?
Give up.
No, not give up. No, if there's an a that's not equal to 1, you know, we could complete the square, but it even makes completing the square pretty hard. We're going to do it today because that's what the test is on. But thinking into the future, what are you probably going to do if you've got a quadratic equation in standard form? X equal, right? You guys know the song, right? You could just do the quadratic formula, couldn't you? Right, in the future. Does that make sense? And you know it's going to work, right? It always works to do the quadratic formula. That's the ace in the hole. And rather than having to do a whole bunch of, you know, trying to find a bunch of factors and, yes ma'am.
It's 15.
Oh, whoops, you're right. It's 15, not 13, isn't it? You're right. Yeah, if I add 9 to -24, it is, sure enough, it's 15, -15. We're still stuck though. We can't find magic numbers, but even if we could, in the future, we'd probably just throw it in the quadratic formula and be done with it, right? Okay, but what about today? We're completing the square, so what are the two things we've got to do to get this?
Add 5.
Got to add 5. Good, good. So we're going to add 5. 3x squared minus 15x equals 5. Now what? Divide by 3. If we're dividing by 3, let's just divide each term by 3, right? So the 3's cancel, that's good, and we end up then with everything looking like it should. We get an x squared by itself, 15 over 3 reduces, right? That's just negative 5x equals, on this side, we're stuck with a 5/3. Okay? So now what? What's our, we got this like we needed it to complete the square, right? So now what is our perfect square on the left gonna be? X minus 5/2, good. Which means what number is gonna have to get added to both sides? So, yeah, so we're gonna square this. 5 squared is 25, 2 squared is 4. It's positive, right? Anything squared is positive. Okay, this one's a little tougher, right? We haven't seen one like this yet. So now what do? We gotta add those fractions up. Okay. Good, so we can multiply this one by 4 and this one by 3 to get a common denominator of 12, right? So that's gonna give us, let's see, 20 twelfths plus 25 times 3, 75 twelfths equals 95 twelfths. Okay? Well, we can't reduce that, can we? 3 doesn't go into 95, how do I know? There's a way I can tell. Remember the trick?
Add the numbers together.
Yeah, add them together. 9 plus 5 is 14, which is not divisible by 3, so 3 doesn't go into it. 4 obviously doesn't go into it because it's odd, right? So we're stuck. So now we're gonna just have to square root both sides. And to get rid of that squared, what's the first thing I'm gonna write? Plus or minus, good. And then when I take the square root of a fraction, you already told me I can break that up into the square root of the top over the square root of the bottom, right? Now what about the bottom? The top, well, are we stuck with the top? Let's just go ahead and see. Let's make factor trees for both the top and the bottom. So for 95, what's one number that guaranteed goes into that? 5. Yeah, it's gonna be 5, but then it's 5 times 19, and 19's prime, so no couples, right? We're stuck with 95 on the top. What about the bottom row? What's that gonna reduce to?
4 and 3.
4 and 3, and what's the square root of 4?
2.
2. So we'll just get 2 radical 3, right? Okay, and on this side, we've got our x minus 5/2. Okay, so all we have to do is add the 5/2 to both sides, but we're still not quite done. What are we missing here? What's wrong with our answer? What's wrong with our answer? Pretty obvious, the way I wrote it.
Being on the bottom.
Yeah, we can't have stranded radical on the bottom, right? So what's our strategy for that? What do we always do if we have a stranded radical on the bottom?
You multiply it.
Multiply what? Be more specific. You're gonna get it right, just be more specific.
Multiply the radical.
What do I need to multiply on the bottom by to get rid of the square root of 3?
Oh, 3, or square root.
Square root of 3, but I gotta multiply top and bottom by the same thing, right? Okay, make sense? And so then what's that gonna give us? On the bottom, the square root of 3 times the square root of 3 is what?
6. I mean 9. Square root of 9.
Square root of 9, which is
Oh, 3.
3. And probably an easier way to think about it is the square root of 3 times itself is the square root of 3 squared, and squaring it undoes the radical, right? Either way you slice it though, this fraction is just going to end up being on the bottom 2 times 3, right? Which is what? 6. That whole thing just becomes a 3. And then on the top, we get the square root of 95 times the square root of 3. So now, even if we make a factor tree out of that, so we don't even need to multiply it out. I know I'm going to have 3 times 95 in the radical, right? So that means we're going to get a 3 and a 95 from whatever that product is. Well, I guess we do need to know. What's 3 times 90? 3 times 9. So 3 times 90 is good, plus 3 times 5. Good, I heard it. 285, yeah. But then the 95 is just going to break up into a 5 and a 19. There's still no couples, right? So on the top, we're just stuck with the square root of 285. So there's our answer, isn't it? X equals 5 halves plus or minus the square root of 285 over 6. Okay? Yeah. All right, let's see. Maybe we're getting pretty close to the end here. I think it's our last completing the square one. I bet we can skip this one. I think you guys we've done one enough like it. Okay, what about this? What do I do here? Okay, if I multiply, really adding and subtracting complex numbers is pretty simple. Multiplying, we got to be a little more careful. When we multiply complex numbers, we're going to distribute like we would if those were x's, right, Wyatt?
Yep.
Okay, good. So we're going to distribute. We've got one quantity times another quantity. So we'll distribute from the first one over the second one. So first, let's take that -2 and distribute it. What's -2 times -7? Positive 14. What's -2 times 9i? Good. And then we've got 11i we're going to distribute to both parts. What's 11i times -77? And what's 11i times 9i? 99 I squared. But what's I squared equal to? -1. Exactly. So that's a -1. So what does the I squared really end up doing? Yeah, all it does is the I squared, you can just erase the I squared and change the sign of the term, and that's it, right? So that last term is just going to become a -99. The other terms we already have. And now we just combine like terms, right? We've got two terms with no i's, so positive 14 plus -99 is what? Negative. What's that going to be? 80. Remember the rule of if you're adding numbers of opposite signs, all you ever have to do is subtract the smaller one from the bigger one, but keep the sign of the bigger one. So what's 99 minus 14? Yeah. And it's going to be negative because the negative one is bigger, right? Okay, now what about the i's? I get -18 minus 77. So what's that going to be? -95. And then we're going to have an I there, right? Because we added the I terms up. And that's it. Okay? All right, real quick, what's that? If you want to write that as a complex number in standard form, what's that going to look like?
Oh, I don't know how to do this.
Okay, so this is super easy, though. Easiest stuff in the world. In the complex plane, here's the real axis, there's the imaginary axis. So what are the coordinates of that point right there?
0, 5.
0, 5. Well, what does that mean? 0 plus 5i, but would we write the 0? No. So it's just 5i. Okay? How about this one? What are the coordinates of that point?
4 plus 6.
4, 6, good. So what's that going to be, Wyatt, then? 4.
That's 6i.
no big deal. And then, I mean, I don't know, we need to do this one, right? If we're adding, we just combine like terms. If we're subtracting, the only difference is, I don't need those parentheses, right? I can get rid of them because there's nothing being distributed. But what do I have to do over here to get rid of the parentheses?
Distribute the negative.
I gotta distribute the negative, good. So if we distribute that negative to both parts, what are we gonna get? -3. Now we just combine like terms. So I get two terms with no i's. 4 minus 3 is 1. 6i minus 7i is -1i, but we wouldn't write the 1, would we? The coefficient of 1. So it's just 1 minus I. Okay, good? You got it. Why don't you work? If you want to test, you can. Just kind of come up to the front and turn your desk around.